previous lecture, what we had done was applied Wilson Sommerfeld quantum conditions to atoms, or what I would say is applied quantum conditions to electron moving in V r equals minus k over r potential, and for a nucleus k was z e square over 4 pi epsilon 0. And what we obtained was that the energy for the nth level was given as whatever some constant, but important thing was there was an n r plus n theta plus n phi modulus square. So, it gave the quantum conditions gave 3 quantum numbers. Let me explain further. So, we have now 3 quantum numbers, n r, n theta and n phi. Let me call this n r plus n theta plus modulus of n phi to be equal to n theta plus modulus of n phi equals k. Then the conditions on these numbers were that n phi varied from minus k to k in steps of 1, because the angular momentum or its component was k times h cross, and it could vary in steps of 1. Also, n for a given k took values n, k, k plus 1, k plus 2 and so on, k plus n r. So, let us now enumerate. If I have k minimum was equal to 1, why? Because Bohr model says that lowest angular momentum for a particle is h over 2 pi. Since this k gave the angular momentum, the minimum value was 1. Let me also remind you what were these quantum conditions. For as many variables as there are in the problem, these were that integral over a periodic motion p x, where x is the variable, dx is equal to n x h. These were the quantum conditions. So, what do we have for an atom now? For an atom, we have n, we have k, we have n phi, and let me call that n phi m, and m goes between minus k and k, and n could be anything, n could be 1, 2, 3 and so on, and k would be equal to either 1, 2, 3 all the way up to n. Remember, n r plus k is equal to n, and nr could be 0, 1 and so on. So, for a given n, a given energy level, right, that energy is fixed E n, I would have n, the quantum number k would vary from 1, 2 and up to all the way up to n, and m which varied from minus k to k, and this would give me structure of atom. And what we anticipate with this, we should be able to explain atomic structure, periodic table and spectra of atoms and so on. So, people started investigating these, because now we had this theory that gave us different quantum numbers, different levels and what all was there. All right. And let us see what are our investigation tools. The tools for investigation are mainly spectroscopy, Remember, this is precisely what gave us the atomic structure, the level structure. So, what one would do is shine light on gas and see different wavelengths. One could also do spectroscopy in presence of magnetic field. What would that do? So, this is I am going to discuss next. You see, whenever there is a particle moving in a circle, a charged particle, for an example an electron, right. So, a particle moving in an orbit represents a current in a loop, and current in a loop, if there is a current I in a loop of radius r, this implies magnetic moment associated with the motion. And just a quick calculation, how much will be the magnetic moment? Magnetic moment is given by area, I am writing area as a vector, times I. Area for a circular orbit will be pi r square, and suppose this direction is z, I will write z unit vector, times I would be frequency of going around. So, this frequency of going around times the charge itself, E. So, right now, let me just worry about the magnitude. So, that I just write the magnitude, which is equal to pi r square nu E. So, let me write this. I am talking about a particle going around, charge E, magnitude, then the magnetic moment is equal to pi r square nu E, which is nothing but pi r square omega E over 2 pi. Nu is the frequency of going around, which is r square omega E over 2. I can write this as mr square omega E over 2m. What is mr square omega? Angular momentum. Is equal to m r square omega, and therefore, magnitude of mu for the magnetic moment. M is the mass of the particle here. Is equal to L E over 2m. In the vector form, I am going to write magnetic moment of a charged particle going in an orbit is going to be equal to E of electron, since the charged particle happens to be electron, L over 2m. And if this is put in a magnetic field, so the energy of the particle is going to be equal to minus mu dot B in magnetic field B. All right. Let us see what are its implications for our atomic structure. So, in the atomic structure, what we had was n level, k level and m level. K is 1, 2 and up to n, and more important m, which represents the z component of angular momentum, is equal to minus k plus 1, minus k plus 2, all the way up to 0, 1, 2, all the way up to k, 2k plus 1 values. And keep in mind, this will be always an odd number. So, if I take an energy level here, it has in it many energy levels, all such that n equals nr plus k plus mod m is the same, right. So, this nth energy level has many energy levels. What happens now if I apply a magnetic field? So, if I apply a magnetic field B, according to different m's that represent Lz. So, I can take this direction in which I have applied the magnetic field to be z. I am going to have different energy levels, different energies. So, all these levels are going to split. So, let us see what happens. I take this atom, here is an energy level E n, and in this, now what is going to happen if I apply the magnetic field, right. So, this is the magnetic field. I am going to have levels split for different m's. So, this could be some m value, let us see how many are there, 1, 2, 3, 4, 5, 6, 7, 8, let me make 9. So, there is 0, there is minus h cross, minus 2 h cross, minus 3 h cross, minus 4 h cross, and h cross, 2 h cross, 3 h cross, 4 h cross. These levels have different energies. So, the energies are going to be minus mu dot B, which is going to be equal to mu z times B. All right. Now, depending on what these values are, so negative energy value levels are going to move up and positive z component values are going to come down. So, this will be 4 h cross B, for example, 3 h cross B, 2 h cross B, and so on. So, these levels are going to split, and therefore, the lines in the spectrum are also going to split. So, suppose I had a line like this which was coming at certain wavelength lambda, this is going to split into nearby lines. And what is going to be the number? Number is going to be decided by how many levels are there. And this number of splittings are going to be odd, because this is precisely 2k plus 1. So, why I am doing all this is to tell you how things progress, and these are, once we have this in our mind, learning what happens later when we solve the Schrodinger equation becomes very easy. But these are things that can be checked experimentally, and when we develop the full quantum mechanics, I should be able to explain all this through proper theory. So, that is fact number 1. So, through spectroscopy of atoms in magnetic field, we can find out the number of levels in an energy level, in an energy state. That is one experimental thing. The other experimental thing that existed was periodic table. And what one said was chemical properties varied in a periodic manner. And in this case, what happened was Li, lithium, sodium, potassium, and so on, they showed similar properties. Beryllium, Mg, and calcium, and so on, they showed similar properties. The atomic numbers for these were 3, 11, and 19. For these were 4, 12, and 20. With difference of 8, periodically the properties change. Not only that, the spectroscopy, the nature of optical lines, that means absorption and emission, also varied in periodic fashion. And also saw that at times the number of lines in magnetic field, number of lines split in magnetic field were even. These are contradicting whatever we have learnt, right. And then there was this famous experiment, Stern-Gerlach experiment, in which they took silver atoms, their beam, and they passed it through an inhomogeneous B, inhomogeneous magnetic field. Why they made it inhomogeneous? Because the force on a dipole arises in an inhomogeneous field. So, if number of m values, that is z component of angular momentum, is odd, what they would expect to see is that the number of lines here should be odd, right. Because if I put something in a magnetic field, the levels split according to the m values, and these values differ. It could be 2 h cross, 0 minus h cross minus 2 h cross, and the corresponding magnetic moment is also different, and therefore, forces would be different. So, I would see odd number of lines. What they got instead was they got 2 lines when the atoms came out. So, this was also at odds with whatever we had learnt. So, combining all these experimental evidences, what was concluded, and people also gave spectroscopic notation to things, that hydrogen had a structure of 1s, helium where n first level goes, the first number shows n value, 1s, 2 electrons, lithium had 1 s2, 2 s1 structure, right. That means there was n equals 1 and n equals 2 were filled, and the nature was S, where S was given a name to a certain spectroscopic way, the spectrum was analyzed. Beryllium was 2s, 1s2, 2s2. Boron was 1s2, 2s2, 2p1. Right? These were all being investigated, and so on. The number of electrons in this level are 2, number of electrons in this is 3 and 4. Similarly, when one reached neon, one could see from spectroscopic and these periodic table evidences that this had a structure of 2s2, 2p6. So, there was certain number that could be filled, right. There was a periodicity of 8. Now, if you look at the corresponding quantum conditions, what they gave you for n equals 1 was k equal to 1, and therefore, m equal to minus 1, 0 and 1. For n equals 2, they gave you k equals 1 and k equals 2. This was m equals minus 1, 0, 1 and m equals 2, 1, 0, minus 1, minus 2. I have reversed the order, and so on. So, what one is seeing here is that in the first n equals 1, there are 3 levels. So, if each level had 1 electron, there should be 3 electrons, and for k equals 2, there should be 5 electrons. This is contradiction to what was observed experimentally. So, let me write this, left hand side is experimental. All right. So, first conclusion that was drawn is k minimum is not equal to 1, rather angular momentum lowest value can be 0. So, if I call this angular momentum quantum number L, it should be actually k minus 1. So, that I am now going to change right here and show it in green. Instead of this, I am going to have n equals 1 and L equals 0, which is k minus 1, and corresponding m value would be 0. N equals 2 would have L equals 0 and L equals 2, 1. This is k minus 1. M value 0, m value minus 1, 0 and 1, and so on. So, lowest angular momentum could be 1, and number 2, more important, electron has a quantum number of its own. That means, it is intrinsic to it. It is intrinsic to it, and it does not depend on where the electron is moving. So, this was called, so electron has a quantum number of its own, and its value is called the spin, and it could have a value h cross by 2 and minus h cross by 2 as the z components of spin. All right. This difference again notice is by one integer. However, what it said was that z component of angular momentum, which I will call spin, let me write this in different color, spin, or intrinsic momentum of electron could be half integer multiple of h cross. Remember what Bohr had said. Bohr had said the minimum value of angular momentum should be h cross, and then it varied as the other integers. However, to explain atomic structure and all that, we had to admit, and this is based on experimental evidence, that spin, the intrinsic angular momentum of an electron, could have the value of half integer multiple of h cross, and the difference would still be 1. So, now we have one more quantum number. And let us call it ms, s for spin. I also point out that we saw earlier that the magnetic moment of electron going around in an orbit was related to its angular momentum as mu equals E L over 2m. What was found in the case of electron, however, for electrons spin and the related the magnetic moment mu s, what was found experimentally to explain the splitting of lines and all that, that in this case mu s was 2 times E spin divided by 2m, and therefore, mu spin z was 2 times E h cross by 2 over 2m, or minus 2 E h cross over 2m electron. So, this was called the gyro magnetic ratio, which is 1 for orbital angular momentum and 2 for the spin angular momentum. The idea of intrinsic angular momentum of an electron, which is called the spin, was proposed by Uhlenbeck and Goudsmit. And then to understand the structure of atom, next Pauli came with his exclusion principle. Which said no two electrons will have all quantum numbers the same. Instead of will have, I should actually now have, can have. So, this becomes a fundamental principle. So, now let us see what we have. We have quantum numbers n, l, m and ms. Now, for a given n and say for a, so we have quantum numbers n, l, m and ms. For a given n, remember what were the k values? K values were 1, 2 and up to n, but we are no more interested in k. Instead, what we have is L, which is equal to k minus 1. So, L values will be 0, 1, 2 up to n minus 1, and this is related to total angular momentum. And for each L, I will have m values which are from minus L to L, right. And then I have the fourth quantum number ms, which could be minus half or plus half. Let us see what does it mean. So, L means the angular momentum is LH cross, that is the magnitude. M means Z component momentum is MH cross, and MS implied spin angular momentum of electron, which is h cross by 2 or minus h cross by 2, in short ms h cross. And when I add that not all quantum numbers can be the same, it explains the periodicity, the rule of 8 and all that, and the spectroscopy. There is one more subtle point for the splitting of levels in magnetic field, which I will explain in a minute, but let us see now for the periodicity of properties of atoms. So, let us see n equals 1, L maximum could be 0, m could be 0 and ms could be plus a half or minus a half. So, maximum number of electrons, let us write on the right, number of electrons in this level could be 2, right. So, 1 for each quantum number. Let us see now n equals 2, L will be 0, m could be 0. So, ms would be plus a half, minus a half, number of electrons would be 2. I would also have in this L equals 1. So, m equals minus 1, 0, 1 for each 2 levels of ms. So, number of electrons 6 and so on. So, one could see the periodicity or how the different levels are filled, and one also observed the way periodicity was built and came up with something called the Aufbau principle, which said that the order in which atomic levels are filled is in increasing number for n plus L, and if n plus L is the same, then lower n is filled first, right. So, let us see that. So, that means n equals 1, L equals 0 will be filled first, n equals 2, L equals 0 and then L equals 1 will be filled. For n equals 3, I will have L equals 0 being filled, L equals 1 being filled, and now I have a competition with n equals 4, L equals 0, because n plus L is equal to 4 for both. N equals 3, L equals 1, and n equals 4, L equals 0. However, now the lower end will be filled first. So, first we will fill n equals 3, L equals 1. Now, how about n equals 3, L equals 2, n plus L is 5, but n equals 4, L equals 1, n plus L is again 5, right. So, let us see now, we are going to now first fill n equals 4, L equals 0 level, and after that I am going to fill n equals 3, L equals 2 level, and then n equals, now I have also n equals 5, L equals 0, n plus L is 5. But first I am going to fill for all these lowest n. So, n equals 4, L equals 1, and then n equals 5, L equals 0. This is the order in which I will fill. Let us see the number of electrons: 2, 2, 6, 2, 6, 2. This is L equals 2. So, this is going to be 10. L equals 1 again is going to be 8, L equals 0 again is going to be 2. Let us see the total number of electrons. Let me now erase this and see what the total number of electrons is. If I fill only up to n equals 1, L equals 0, I have 2, 4, 10, 12, 18, 20, 30, 38, 40, and so on. These are the shell fillings, and this is where the periodicity starts coming in. These are the shell fillings, all right, and so on. So, this is how the atomic structure was explained. Now, the Aufbau principle at times is also written like this. You write the levels 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, and so on, and then you fill them according to this arrow. So, you start with 1s, then you fill 2s, then you fill 2p, and after 2p you fill 3s, 3p, and after 3p you cannot go to 3d, you cannot go this way, you have to go to 4s, and then you come to 3d, 4p, 5s, and so on. So, this is known as the Aufbau principle. It is followed by maximum, a large number of atoms in the periodic table, and this is how the levels are filled. So, to conclude this, what we have learnt in this lecture is that angular momentum of electron in an atom could have values L equals 0, h cross, 2 h cross, and so on. And then we all have also learned that there is spin angular momentum, which is h cross by 2 and minus h cross by 2. And by the way, this two values of spin angular momentum are what gave rise to the split of the beam of silver atoms in Stern-Gerlach experiments into two. And then we have the Pauli exclusion principle, that no two electrons can have all numbers the same. And with this, I conclude this lecture. I have given you a piece of history mixed with what we know today, that this history is discussed because it is important to know how ideas developed. And all these things, you can see that Sometimes when we are describing angular momentum, we are saying k equals h cross, then suddenly we are saying with experimental evidence there should be not k h cross, but k minus 1 h cross, right. Then the idea of spin angular momentum also came to explain certain properties. Pauli exclusion principle was introduced to explain the periodicity and the filling of atomic shell structure. All these things should be preserved. These are experimental facts which were explained using these principles which are being stated. All that should be preserved and should come out automatically from a complete theory, which we will see later when we develop the quantum mechanics, that it does come out.